A tissue culture incubator is an essential tool for numerous fields such as drug discovery, personalized cell-based therapy, and research. They provide a controlled environment that simulates the conditions inside a body for cell cultures to grow. Embrient Technologies has re-engineered the tissue culture incubator from the ground up to address problems that are inherent in conventional incubator designs. We have obtained 2 patents with almost 40 claims covering the various technologies, and a third is pending. The first issue with conventional incubators is their reliance on recovering the environment rather than preventing its loss. This loss occurs every time the door is opened, and their recovery times are bad enough that manufacturers often choose to publish recovery times to only 90% of set point. For example, a major manufacturer advertises 6 minutes for recovery, but in reality, it takes about 15 minutes, and some parameters like humidity can take over 45 minutes. Our innovative airflow system eliminates the problem of recovery using the proven technology of air barriers, often used for industrial refrigerated rooms, which forces any ingress to pass through a second recirculating outer chamber that buffers, filters, and amends the environment before being allowed to diffuse into the inner volume. A second problem with conventional incubators is contamination. In addition to complying with ISO Class 5 cleanroom standards and 12 log SAL, an industry standard for heat-based decontamination, we integrated a second external air barrier which provides a shield against foreign contaminants. We also designed the air path to ensure that any intruding particle must first go through the outer chamber for filtration and decontamination, via a PCO and UV process, along with a secondary filtration stage to remove any volatile organic compounds. We took advantage of machine learning algorithms to control every aspect of the incubator, from the automated process of opening of the door to adjusting the laminar flow vanes and air velocities to compensate for transient as well as static disturbances. Machine learning also allows us to use redundant sensors to not only provide stable operation during a sensor failure, but allow faster stabilization from a cold start or deviation by placing the sensors in strategic positions in the air path. We use an adaptive artificial neural network to optimize parameters based on the data collected by sensors within the incubator as well as user input. Each incubator can be cloud-enabled for logging, monitoring, data collection, auditing, and alerting. Access can be controlled through security policies, which include various authentication methods such as facial recognition using the integrated camera.